Hello students, today we are going to start centrifugal pump. What is centrifugal pump? Centrifugal pump is the reverse of hydraulic turbine in terms of work done. In the hydraulic machines which convert the mechanical energy into hydraulic energy are called pumps. The hydraulic energy is in the form of pressure energy. If the mechanical energy is converted into pressure energy by means of centrifugal force acting on the fluid, the hydraulic machine is called centrifugal pump. The centrifugal pump acts as a reverse of an inward radial flow reaction turbine. This means that the flow in centrifugal pump is in radial outward direction. So you have to remember all the direction of flow in centrifugal pump is radial outward directions. The centrifugal pump works on the principle of forced vortex flow. So this is also an objective question. The centrifugal pump works on the principle of forced vortex flow, in which means that when a certain mass of liquid is rotated by an external force, the rise in pressure head of the rotating liquid takes place. The rise in pressure head at any point of the rotating liquid is proportional to the square of tangential velocity of the liquid. At that point, rise in pressure head will be equals to v square upon 2g or omega square r square upon 2g, where omega is the rotation angular velocity of the fluid. Thus, at the point of impeller, at the outlet point of the impeller, where radius is more, the rise in pressure head will be more, and the liquid will be discharged at the outlet with a high pressure head. Main parts of the centrifugal pump are the liquid can impeller, be casing, suction pipe with a foot valve or strainer, delivery pipe. The impeller is the rotating part of centrifugal pump and it is called impeller. It consists of a series of backward curved vanes. So it is also an objective question which can be asked in exams, that the impeller have backward curved vanes. The impeller is mounted on a shaft which is connected to the shaft of an electric motor. The casing of a centrifugal pump is similar to the casing of a reaction turbine. It is an airtight passage surrounding the impeller and is designed in such a way that the kinetic energy of the water discharged at the outlet of the impeller is converted into pressure energy before the water leaves the casing and enters the delivery pipe. The following three types of casings are commonly. Figure shows the volute casing which surrounds the impeller. It is of a spiral type in which area of flow increases gradually. The increase in area of flow decreases the velocity of the flow. The decrease in velocity increases the pressure of water flowing through the casing. It has been observed that in case of volute casing, the efficiency of the pump increases slightly as a large amount of energy is lost due to formation of eddies in this type of casing. So in this figure, this one is the volute casing, and these are the main parts of centrifugal pump. This is the eye, this is the impeller, this one is the casing, and this is delivery pipe, and this one is the suction pipe. This one HS is the suction head, HT is the delivery head, and the water enters through suction pipe at the eye, and due to high velocity of the impeller, the water rotates around the casing, and the shape of the casing is of continuously gradually increasing area. So velocity head converts into pressure head. Vortex casing: if a circular chamber is introduced between the casing and the impeller as shown, the casing is known as vortex casing. By introducing the circular chamber, the loss of energy due to formation of eddies is reduced to a considerable amount. Thus, the efficiency of the pump is more than the efficiency when only volute casing is provided. Third one is the casing with guide blades. This casing is shown in the figure 19.2b, in which the impeller is surrounded by a series of guide blades mounted on a ring which is known as diffuser. The guide vanes are designed in such a way that the water from the impeller enters the guide vanes without shock. So this is the figure of vortex casing, and this is the figure of casing with guide blades. So this one is the impeller, This is the vortex chamber, and this is the casing. In this one is the impeller, and this is the guide vanes. Also, the area of the guide vanes increases, thus reducing the velocity of flow through guide vanes and consequently increasing the pressure of water. The water from the guide vanes then passes through the surrounding casing, which is in most of the cases concentric with the impeller as shown in figure. Suction pipe with a foot valve and a strainer. A pipe whose one end is connected to the inlet of the pump and other end dips into water in a sump is known as suction pipe. A foot valve, which is a non-return valve or a one-way type of valve, is fitted at the lower end of the suction pipe. The foot valve opens only in upward direction. A strainer is also fitted at the lower end of the suction pipe. And last one is the delivery pipe, a pipe whose one end is connected to the outlet of the pump and other end delivers the water at a required height is